Alright guys, I want you to keep your homework on your desk. That does not mean you're checking answers with anyone around you. Okay, just keep it flipped over on your desk, and you're going to need your calculator, journal, and pencil pouch. You'll also receive this half sheet where it says TI-84 Graphing Calculator Notes. Go ahead and glue that in. And once you have that glued in, we're going to take a look at what you just glued in. So, a couple things I want to point out to you. Okay, number one is whenever you get stuck, we've discussed this already, and your calculator isn't quite working very well, to reset your calculator, you're going to click all of these buttons. So let's go ahead and do that. Get your calculator out. Mine has a lot of stuff on it now. Doesn't matter though. So I want you to follow these directions. Push the second button, which is the purple button. Plus sign. Okay, you're going to go down to 7, which is the reset. You can use the arrow, or you can just push 7. Then it says 1, which is all RAM. We're clearing everything. And we want to reset everything, which is 2. And it should look like this, where everything is cleared and we're ready to go. Okay, so that's the clear everything. The next two I want you to highlight. There's actually a way you can find the slope on your calculator from 2 points in a table just by entering it in. And I didn't want to show you this until now. So make sure you highlight those. Those are the two ways to find the slope. And then the last way is just how to type an equation into your calculator. So again, remember when we have an equation in the calculator, we go to the y equals. And we would type in whatever we have, let's say 5x plus 2. I would hit graph to see the equation on a graph. And I would hit second graph to see the table. Second graph to see the actual points that are on that line. So that's just a recap. Okay, so let's take a look more in depth on how to find the slope from a table. So we're at this one right here. So I'm going to give you a table. Let's say x and y. And this is the table. Let's say 2, 4, 6, and 22, 32, 42. Okay, this is the table that they give us, and we want to figure out what the slope is. So we know how to do it by hand. We could do y2 minus y1 over x2 minus x1, or we can find the change of y over the change of x, or we can use our calculator. So lots of different ways. So what I want you to do is find the stat button where it says stat. Okay, notice it's the second one to the right of the alpha button. So push stat, and then 1 edit. So I'm going to push 1. It's going to edit. Now this is your L1, L2 table. The L1 represents your x values. The L2 represents the y values. So for the x values, I'm going to push 2, enter. Then 4, enter. Then 6, enter. Okay, so I have 3 table values. Okay, so now I'm going to use my right arrow button and go over to the L2 side, which represents my y values. Okay, so I'm going to enter in 22. And notice 2 and 22 are a point, so they should be lined up together. 4 and 32, so I'm going to push 32, enter. And then 42. Okay, check your neighbors to make sure theirs looks like mine and yours. Notice I have 3 here and 3 here. It will not work if I accidentally typed in another number. Okay, it has to be equal. Okay, now to figure out the actual slope, we're going to look at the next button as well, or the next thing. And what we're going to do is push stat again. And we're going to go over to the right calc. Let's go ahead and write this down. So after this part right here, I want you to push stat, and then go over to the right to calc. So again, we had stat, looks like this. We're pushing over to the right for calc. And then we're going to go down to where it says for lin reg. So I'm going to put for lin reg, and that stands for linear regression. Notice it also has ax plus b. They use a instead of the m. So it's ax plus b. Push enter. Okay, this is just saying your L1s were your X's, which is true. Your L2s were your Y's, and we're going to go all the way down, so scroll down to calculate. Push enter. Notice it gives you the equation y equals ax plus b, so the a is our m, and my slope here is 5. Okay, what's the y-intercept? 12. So my equation here would be y is equal to 5x plus 12. So that will work for any table that you plug in if it's linear to find the slope. Okay, what I want you to do is look at number 1 on your homework. Okay, let's enter in table 1. So go to your stat button. Okay, edit. Now we want to clear what we just did. So what you're going to do is highlight L2. So I just moved my arrow up where it's highlighted. You're going to push clear, enter, and it will clear everything. Then move your arrow up to L1, push the clear button, enter. Check your neighbors and make sure that yours looks like theirs. Now let's enter in the first one, because again your homework wanted you to find the slope. So I'm going to enter in 3, enter, 6, enter, 9, enter, 12, enter. And the y values are 1, enter, 2, enter, 3, enter, 4, enter. Again, I have 4 and 4, so I know I did that correctly. And now I want to find the slope. So I go back to the stat, go over to the right, calculate. I want to find the lin reg, enter. Okay, again, L1 are my X's, L2s are the Y's. Go all the way down to calculate. And your answer here for the slope should have been 1/3 or 0.333. So if you got that correct, there you go. That's so far so good. You're going to have time to check your answers shortly. Give you about 5 minutes to check as many answers as you can, but I just wanted to show you that. Okay, that's from a table. Okay, it works the same way from just 2 points. So say I give you 2 points. Let's say 4, -1, and 7, -12. Okay, these are the 2 points that the line goes through. We want to find the slope. So I'm going to do the same exact thing. These 2 points are the same thing as if they were on a table. So I'm going to go to stat again, edit. I'm going to clear my L2 and L1, so highlight the L2, clear, enter. Highlight the L1s, clear, enter. And I'm going to go ahead and enter this in. So the X here is 4. The Y that matches up with the 4 is -1. The next point is 7, so I'm going to enter 7, enter. Then I'm going to use my right arrow. 7 and -12 go together. So I'm going to enter that in. So I have my 2 points, and I use the same exact buttons. Okay, this time the buttons are written out here. So I go to stat, calculate, so over to the right one, down to lin reg, scroll all the way down to calculate, and the slope here, again, ax plus b, the a is the slope, it'd be -3.66 or 2/3, -3 2/3. The y-intercept here is 13.66, 13 2/3. So again, if I look at number 3 on our homework, say I pick 2 of these points. Let's pick this point, which in this case would be -1, 0. And let's pick this point, which would be 1, 2. Okay, go ahead and use your calculator to figure out the slope for these 2 points. So I'm going to go to stat. You can move ahead of me if you want. Clear what I have. I'm going to enter in my points. -1, enter, 0, and 1, 2. So now when I figure out the slope, I'm going to stat, calculate, lin reg, scroll down to calculate, and your answer here for the slope is 1. your y-intercept is also 1. And look, it crosses over the y-axis at 1. So that's how I would get my equation. Okay, so what I want you to do is keep your notes out on your desk. I am giving you 5 minutes to check over as many questions as you can with your calculator. And then after those 5 minutes, you will turn your homework into the tray. Miss Osborne will grade that. You will not grade it as a class. So 5 minutes to check your answers. Miss Osborne will tell you when those 5 minutes are up. And then when you are done, you're going to go ahead and head the next page in your journal. 3.2, direct variation. Today is October 5th. And go ahead and head your table of contents with your page number. Okay, now that your homework is turned in and your next page in your journal is headed, 3.2, direct variation. Okay, direct variation is something that you learned in 7th grade pre-AP, and it's very, very similar to something that you probably use a little bit more vocabulary-wise. So let's write down the definition for direct variation. Okay, what direct variation is it is the same thing as a proportional relationship. And I want you to highlight that. Direct variation is the same thing as being proportional. Now, what is proportional? Okay, the first thing to make something proportional that I always look for is that line passes through 0, 0, or the origin. Okay, the line passes through the origin. For instance, if I have a graph, okay, if it passes through the origin at 0, 0, it goes through the origin. That would be proportional, or a direct variation. If I was looking at an XY table, what point would I see on the XY table? I'd have to see 0, 0. So 0, 0, 1, 2, 2, 4. Okay, that would be considered proportional. Okay, because it has that point 0, 0. I'm going to go ahead and highlight that. So it has to have that point. That's the first way it could be proportional or a direct variation. The second thing it must have to be proportional or a direct variation is that the slope of the line is constant, which makes it a line. Constant slope or constant rate of change makes that a line. Now the formula that they use for direct variation is y is equal to kx. Now what does that remind you of? It should remind you of y equals mx. Okay, now these both mean it's proportional or direct variation, which means it goes through the origin. So if I'm thinking about y equals mx, what's the b here? If it goes through the origin at 0, 0, what's the y-intercept? Has to be 0. So that's why there is no b. There's no y-intercept here because it's 0. So that's where they came up with the equation y equals kx. M and k mean the same exact thing. Now, the way that I remember that is, since the slope is our constant rate of change, in math class we're going to spell constant with a K. Don't tell your English teachers. But that just tells me that it has to be constant. It's a constant rate of change. If it has that and no B, okay, I know it's a direct variation or it's proportional. So let's figure out from an equation how to identify if it's a direct variation or not. So here's an example. Let's do 7y is equal to 2x. So I want to figure out if this is a direct variation. So I want to get it into y equals mx plus b. So I'm going to go ahead and write y equals mx plus b at the top and line up my equal sign. Now we worked on this when we were solving for multi-step equations. How do I get y by itself here? Right now it's being multiplied by 7, so I need to undo that by dividing by 7. Whatever I do to one side, I have to do to the other. And that leaves me with y is equal to 2/7 x. Now, is this equation a direct variation or proportional? Same thing, okay? Is the slope of the line constant? Does it have a k? Yeah, okay. Our constant of variation, okay, remember I told you when we labeled our notes? Let's write that down actually. Our constant of variation, again, is our k. In this case, it'd be 2/7. Is it proportional? Does it go through the origin as well? Yeah, there's no b here, okay? So this would be considered a direct variation. Okay, try this one now. Try 3y plus 4x equals 8. Again, we want to get this to y equals mx plus b to determine if it's proportional or a direct variation. So the first thing I'm going to move is probably this x. How do I get rid of this 4x and move it to the other side? I'm going to subtract 4x on both sides. Remember, we write it off to the side because I can't combine these like terms. So I'm left over with 3y is equal to negative 4x plus 8. Okay, I'm not quite finished here. To get y by itself, how do I get rid of that multiplied by 3? I have to divide by 3 on both sides, so I divide this whole side by 3. And I rewrite the equation as two fractions. So negative 4/3 x plus 8/3. Okay, so this is my equation. Okay, what's the constant of variation here? Or the same thing as my slope. So we'll put constant of variation is negative 4/3, which is okay. But is this proportional? Does it go through the origin? No, right? Because it goes through the y-axis at 8/3. So this would be considered not a direct variation. Okay, so things that we just did that you need to remember from an equation is the first thing that we did on both of these occasions is we want to move the variables to create y equals mx plus b. Okay, that's the first thing. We want to move everything to make it into our equation. But the most important thing is from an equation, if there's no b, it's a direct variation. If there is a b, so again, no b is a b. If there is a b, then it is. It's not a direct variation. So at the bottom, I'm going to put if b is equal to 0, that means it's a direct variation, or it's proportional. If b is equal to a number, negative, positive, doesn't matter, this is not a direct variation. Now I want you to highlight those two. Again, when we're dealing with an equation, if b is 0, that means it goes through the origin and it is a direct variation. And if b is a number, it's not a direct variation. Okay, that was from an equation. Now let's determine the direct variation from a table. So again, our equation here for any direct variation is y is equal to kx. K is our slope. So I need to find the slope from my table. Okay, and the way we do that is to find the k. I have to use y over x, and that should be very similar to something you've heard already. Remember, change of y over change of x. K is equal to y over x. So let's determine if this table is a direct variation. I have 4, 6, 8, and 12, 10, and 15. Go ahead and copy that down. Now again, this is to determine if it's a direct variation or not. So if I look at this first table, I have my x's and my y's. Okay, again, the formula here is y over x. So for this first point, okay, I'm going to take 6, which is my y, over 4. Okay, to simplify that, I can cut both those in half to 3 over 2. Okay, so far, our constant right here is 3 over 2. We have to check every single point, though. So again, y over x for the next point, 12 over 8. I can cut both of those in half, or I could divide by 4, and I end up getting 3 over 2. So far the constant is the same. Let me check the last point, though. 15 over 10. Y over x, I end up getting, those are both divisible by 5, 3 over 2. Okay? And what that's telling me is, since the k is all the same, this means this is a direct variation. So the same k means it's a direct variation. And that's from a table. Okay, let's look at another table. Let's go ahead and copy this down. Let's do negative 2, 1, and 4 for the x values. And then 3.2, 2.4, and 1.6. So again, to determine if this is a direct variation, I'm going to use y over x. Change of y, change of x. So for this first point, I'm going to do 3.2 over negative 2. Now that's not a pretty fraction, so I'm going to use my calculator. 3.2 divided by negative 2. This one we're just going to keep as a decimal. So let's do negative 1.6. Again, we can keep it as a decimal just because we're trying to just determine if it's a direct variation or not. Next point, 2.4 over 1, y over x. Well, that's easy. That's 2.4. So I don't even have to check that last point, 1.6 over 4, because the constant's not the same. So this would be an example of a table that's not a direct variation. Okay, they have to have the same constant rate of change, and they have to have 0, 0. Okay, and then the last thing we're going to look at is we looked at from an equation, from a table, and now we're going to look at from word problems. So I want you to title this, or skip a line and put writing direct variation equations. So I'm going to give you how it's worded on the EOC. We're going to do 2 examples together, and then we'll recap more of this tomorrow. We're going to play a fun little game at the end. So again, our formula for direct variation that they give us is y is equal to kx. But to find the k, which again up here, the k was just y over x. Y over x, that's to find the constant. Okay, so to find the k, we have to do y over x. Once you have that written down, someone is going to hand out just 2 problem examples so we don't have to write these down. Go ahead and take a second to glue that in. And when everyone's ready, we'll begin. Okay, once you have that glued in, okay, we're going to look at these 2 examples. These are from past EOCs. This is how they're worded. So let's take a look at what they are. Okay, it says, suppose y varies directly with x. Okay, that sentence right there. Y varies directly with x. That's telling you that it goes through the origin and there's a constant. Okay, that's also telling you y is 35 when x is 5. Okay, so it says what direct variation equation relates x and y? Okay, so let's begin with just the first part. We know it varies directly, so my equation for a direct variation is y is equal to kx. I know that for sure. And what they're saying is, suppose y varies directly with x, y is 35 when x is 5. Okay, so they tell me y is 35 when x is 5. Okay, what direct variation equation relates x and y? And then what is the value of y when x is 9? So this is what they're telling me. I want to figure out what k is. So, to figure out what the k is, now this one's easy to think about. What times 5 gives you 35? Or I could divide by 5 on both sides. Or to find the k, remember we have this equation where it's k is equal to y over x. So let's plug in what we know. They give me the y is 35, and they give me the x is 5. That tells me that k is 35 divided by 5, which is 7. Okay, so far we know that. We figured out 2 different ways. So now it says, what is the value of y when x is 9? Well, if we want to find the value of y when x is 9, let's write down our formula. Y is equal to kx. Do I know the y? What is the value of y? No, that's what I'm trying to find. Do I know the k? Yes, I just found it out, which was 7. And they want me to use 9 for the x. So again, what is the value of y when x is 9? Well, if I solve this, 7 times 9 is 63. So I solved that by doing a lot of steps. Let's try another one. Suppose y varies directly with x, so I know my equation here is y is equal to kx. And they'd say when y is 10, x is negative 2. So we want to figure out what the k is. So k is y over x. I have 10 over what number? Over negative 2, which leaves me with k is equal to negative 5. So the constant is negative 5. Now they want me to do the next step. What is the value of y when x is negative 15? So let's use our equation. What is the value of y? That's what we want to solve. We found k is negative 5. and x is negative 15. And all I have to do is multiply those two together. 2 negatives makes a positive. 5 times 15 is 75. So my answer here would be 75. That's how questions are asked on the EOC about direct variation. You have to use your formula. We have to find the constant of variation, and then we just plug it in with what they want me to find. Okay, we'll recap more of this tomorrow. What I want you to do right now is put your notes away. And what you're going to be given, do not put your name on this. It says direct variation snowball at the top. When you get this, again, do not put your name on this. I want you to, on the back, draw an X, or draw your four corners. I want you to recopy, so equation and table go at the top, so we'll put equation and table, and we'll say graph and definition. So you're really just recopying everything on the back. Equation, table, graph, definition. And when everyone's ready, I'll begin by explaining what to do. Okay, what you notice is this is a snowball, and we're going to have a snowball fight. Now the rules for the snowball fight is, once I tell you to, you may crumble this up, and you may throw it on the count of 3 with Miss Osborne's counting, or countdown, and you must throw it below the shoulders. You will not aim it at anyone. Okay, we're just throwing it in the room, and then we're going to find a loose snowball. So this is how it works. The front side is direct variation snowball. Okay, you can choose any one of these 4 squares. So you can make up an equation, that's direct variation. You can make up a table. You can draw a picture of a graph that shows a direct variation, or you can define a direct variation. So what I want you to do right now is take a second to fill in one of those squares. And I want you to crumble it up and sit quietly while we wait. Okay, once it's crumbled up, Ms. Osborne will count to 3. You will stand up, actually stand up right now. Ms. Osborne will count to 3, and you will throw your snowball across the room, not at anyone, not aiming at anyone. Okay, and you will have 10 seconds to retrieve a snowball and sit back down at your seat quietly. Do not open up your snowball. Okay, go. 10, 9, 8, 7, 6. Remember, you're finding a snowball, sitting down. Do not open it. 5, 4, 3, 2, 1. Every single person should have a snowball. Go ahead and open that up. Okay, my snowball, the person that I collected, wrote an equation of a direct variation. I'm checking the thing that person wrote. So this equation is y is equal to 7x. That is a direct variation because there's no b. So we're good. I don't have to make corrections. If the person's paper that you have was wrong, you need to make a correction. So say this was plus 2, okay? So say I have plus 2 here. I would cross this out, and I might just put y is equal to 7x, okay? Because again, there's no y-intercept for direct variation. Okay, so check the person in front of you. Now, you have 3 options. The other 3 that the people did not fill out yet. You are going to create a table, a definition, or draw a picture of a graph of a direct variation. And you're going to repeat the same process. Once you have that filled out, you're going to crumble it up on your desk. Wait patiently. Miss Osborne will tell you to stand up. Give a count of 3. You're going to throw your paper, and then you have 10 seconds to collect one, sit down, and do the same thing. You'll repeat this for the front side as well as the back side. Again, the back side represents non-proportional. So you'll write an equation for a non-proportional, or not a direct variation, not a direct variation table, not a direct variation graph, and not a direct variation definition. At the end, whatever paper you have left, okay, the very last one, okay, you have to check all 8 squares because this will be your paper. You will put your name at the top on the front side, and we will collect this, and this paper will be your grade, even though there's going to be multiple people's work all over. So it's your responsibility to check that the 4 on the front represent a direct variation and the 4 on the back do not. Okay, enjoy. No homework tonight, and I will see you tomorrow.